Okay, so we learned how to calculate the pH if we're given the hydronium ion concentration. What if you have the pH and you need the hydronium ion concentration? In other words, doing that calculation backwards. So the equation we used was pH equals the negative log of the hydronium ion concentration. Rearranging this equation is not as straightforward as, say, a gas law equation because it's not just multiplying and dividing or adding and subtracting. We've got a function in here, this logarithm. So I am going to show you how this gets rearranged to this equation because the students at a higher level will hopefully appreciate that. And I want you at least to have seen that, but I don't expect you to be able to do that. The goal is that you can, if given this equation, you can calculate the hydronium ion concentration. So let's look at this. So if I want to isolate the hydronium ion concentration, I need to get rid of this negative sign and I need to get rid of log. Well, the first thing I'm going to do is I'm going to multiply both sides by -1. So that's going to make the pH negative, and it's going to make this side positive. I can't divide by log to get rid of it because it's a function. I have to do the opposite of the function, which is the antilog. So antilog is 10 to the x. So I'm going to take, I'm going to do 10 to the x on both sides of the equation. So that's going to give me 10 to the minus pH. It's going to be equal to 10 to the log of the hydronium ion concentration. 10 to the log of something is just that something. So this is just equal to the hydronium ion concentration because log and antilog cancel out just like matter and antimatter. And so there we have the equation. The hydronium ion concentration equals 10 to the negative pH. So on your calculator, there should be a 10 to the x button. This is not your scientific notation button, EE or EXP. It's 10 to the x. It's often the alternate function on the button that says log, because it's the anti-log, or it's going to be nearby. So you need to figure out how your calculator works so that you can do these calculations. So let's just make up an example. Let's say the pH is 3.95. So pH equals 3.95, and then we want to know what is the hydrogen ion concentration. Well, the hydronium ion concentration will equal 10 to the negative pH. Well, the pH is 3.95, so 10 raised to the negative 3.95 power. So we can't leave it like that because that's like a non-standard form. On my 36X Pro, I do these problems in the forward direction. So I'm gonna put in a negative sign. This calculator has natural log and log on the same button, and what you do is you press it twice to get the LOG, and then I'm going to put in, wait a minute, I don't want negative. I'm just, yeah, start over on that one. I'm doing 10 to the x. 10 to the x. So I press that button twice so that it gives me 10 to the little box, and then I put in minus 3.95, and I press equals. And what it displays is 0.000112202, which would be 1.1 times 10 to the minus 4. And the unit will be the molarity. If you have a TI-30X, that calculator, you kind of work things like this backwards. And so you put in 3.95, you change the sign, and then you press the 10 to the x button. Any questions? We'll have time after this lecture to try it out on your calculator. So here's another example. Calculate the hydronium ion concentration for a solution with a pH of 8.37. Now on exam 5, I'm going to give you all of these pH equations, but on the final exam, they are not provided. And there's really only a couple of them, so you can memorize it. So if we want the hydronium ion concentration, again, we're going to use hydronium ion concentration as 10 to the negative pH. So here, this would be 10 to the minus 8.37. Do that on my calculator. And I'm going to get 4.265 times 10 to the minus 9. I'm going to round that to two significant figures, 4.3 times 10 to the minus 9 molar. Yeah. No. So what your calculator, and mine did this too, it'll give you a 0.0, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 4. Okay. So it's showing it to you in decimal notation because it can, just barely. But there are digits after that. So you need to make your calculator show you the rest of the digits. What kind of a calculator do you have? The 30X. So on the 30X, what you're going to do is you're going to press the second function and the number 5. If you look above the 5 button, it says SCI. That means scientific notation. And so then it'll show it to you in scientific notation. Does it do it? On some calculators, you need to go into a mode function and select scientific notation. So that's another thing that we can work out individually in lab today. Make sure that you know how to do that. Sort of a hack method for getting it to show you the rest of the digits is you can count over and find out what the exponent is in scientific notation, and then take that number and multiply it by 1,000 or 10,000 to move the decimal point over so it'll force it to show you the rest of the digits. That's kind of a hack method. It's not very elegant, but it gets the job done. Okay? Any other questions? So there's the pH scale. There's also the pOH scale. And this is the same as pH, but instead of looking at hydrogen ion concentration, we're looking at hydroxide ion concentration. So if you notice this pOH equals negative log of OH, that's very much like pH equals negative log of hydronium ion concentration. It's the same equation, we're just looking at a different ion. Okay, so we do those calculations in the same way. There is a relationship between pH and pOH that is very simple and convenient. And so I'm going to show you another derivation. And again, if you don't like these, just think about balloons or puppies or something. So we know that the hydronium ion concentration times the hydroxide ion concentration equals what in water? 1.0 times 10 to the what? Negative 14. Okay. This is called the ion product constant of water. So if I take the logarithm of both sides, when I take a logarithm of things that are multiplied, then I get the log of the one thing plus the log of the other thing. And if you're interested in how logarithms work, I'd be happy to talk to you about them. Once you see what they're actually doing, they're really, really cool. Logarithms were used before we had calculators to do multiplication by adding. And they used slide rules and very cool stuff. So the log of this side equals the log of that plus the log of this. What is the log of 1 times 10 to the minus 14? It's minus 14. Not the pH, but just the log. So the log of that side is negative 14. Well, I want to get rid of this negative sign. So I'm going to multiply both sides by negative 1. So that's going to give me negative log of hydronium ion concentration plus negative log of the hydroxide ion concentration is equal to positive 14. Just change the sign on everything. What does this equal? pH. And this equals pOH. So pH plus pOH equals 14. What? Isn't that a simple little equation there? The pOH plus the pH add up to 14. So if I know the pH, it's very easy to find the pOH. I just subtract the pH from 14. And this 14 can be considered an exact number. You don't worry about sig figs with that. So now I want to show you what I call the circle of pH. Let's see if I can draw it better than I did yesterday. So the circle of pH. We have 4 different things that we've been calculating. We've calculated the pH. We've calculated the hydronium ion concentration. We've calculated the hydroxide ion concentration. And we can calculate pOH. So these make what I call the circle of pH. It's like the circle of life, but without the music and the lions. Can't spell today. Hopefully I can talk today, because yesterday that was an issue. So these double-headed arrows represent that you can calculate pH if you know the hydronium ion concentration, or if you know the hydronium ion concentration, you can calculate the pH. And I've shown you both of those equations. I'm going to make this one colorful. So we know that pH is the negative log of the hydronium ion concentration. And I showed you today that you can calculate the hydronium ion concentration by taking 10 and raising it to the power of negative pH. I just showed you how to get between pH and pOH. We know that they add up to 14. So pH plus pOH equals 14. Going between hydronium ion and hydroxide ion concentration, that's the first equation we learned in this chapter. The product of those two concentrations is 1.0 times 10 to the minus 14. And over here, pOH and hydroxide ion concentration, those are the same equations, but instead of having H, you put in OH. So it's not like you actually have to memorize any more equations. pOH is the negative log of the hydroxide ion concentration. And the hydroxide ion concentration equals 10 to the negative pOH. And that's the circle of pH. So if you're given pH and they ask you for hydroxide ion concentration, you can go around the circle to the right or you can go around the circle to the left. Do not try to cut across the middle of the circle.
Is there no way?
Well, I'm sure there is a way, but I wouldn't. Some shortcuts are more work. This is, you've got like barbed wire or something in the middle. Yeah, you could go straight through, but you're going to get cut up. Don't do it. Just walk around. Yeah.
Can you always be given something?
You have to start with something. Like one of the questions on at the end of experiment 14, it gives you a mass of HCl and a volume and asks you to calculate the pH, right? Well, so you're trying to get pH. You need either the pOH or the hydronium ion concentration to calculate pH. Well, you don't have any information about that, so you want the hydronium ion concentration. So HCl is a strong acid. It's got one hydrogen ion. So the concentration of hydronium ion will be the same as the concentration, the molarity of the acid.
We will have some of those something that's not given as like the pH for that.
On an exam, probably not. You'll probably be given one of the four things on this circle and asked for one of the other things. On an exam, that's what's going to happen. Yeah. Personally, I like to avoid this because it's just messier. I'll tend to go around the other way because I like this one a lot better. Just subtracting from 14 is a lot easier than taking 10 to the minus 14 and dividing by something else. So that's the circle of pH. So let's do this example. Calculate the hydroxide ion concentration for a solution with a pOH of 4.25. So this is just like the question we did with calculating the hydronium ion concentration from the pH. Hydroxide ion concentration is going to equal 10 to the negative pOH. So 10, and the pOH is 4.25, so 10 to the minus 4.25. 10 raised to the negative 4.25. My calculator shows me 5.623 times 10 to the minus 5. Bless you. And I'm going to round that to 5.6 times 10 to the minus 5 molar. So I think I mentioned this in lecture yesterday. For pOH or pH, the sig figs are after the decimal point. So a pOH of 4.25 has two significant figures. And so then when I calculate a concentration, I'm going to round it to two significant figures. I will not try to trick you on that on an exam or anything, but I do want you to at least have heard how sig figs work, because there's a lot of people who don't get it.
So the molarity, could it also be H3O plus as well?
Well, from this we could calculate the hydronium ion concentration.
But while looking for the H3O plus, like, would you also get a molarity for that one as well?
Yes.
So like, it could be either one, so we can assume that it's one or the other.
Well, from pOH, you're going to get hydroxide ion. From pH, you'll get hydrogen ion.
Yeah, but I'm saying if the question gives you the molarity, you kind of assume that it's OH negative off the bat.
No, no. Because the molarity could be
Either one.
either one. They have to tell you the molarity of what. Any other questions?